I'm going to pass you over to Dr Samantha Pearman Kanza, who's going to do the first session of the day.
So yeah, we want to kick this off by talking about the barriers and considerations of electronic research implementations. So as I said, just to give you a bit of context, I've been looking at this stuff for about 10 years. For my PhD, I looked at, I guess, a lot of this, pretty much all of the barriers and all of the reasons that people don't use electronic research notebooks. Some of those are evolved somewhat, some of them are quite similar to what's going on now. And have also gained quite a lot more insight by working on a number of different case studies of people who've actually gone through the journey of properly implementing electronic research notebooks and electronic lab notebooks, including Matthew and myself, who have been implementing a trial at the University of Southampton, and Philip, who's also part of PSDI, has been implementing OneNote, a more generic notebook in our undergrad labs. So yeah, actually working on these things really hands-on provided kind of even more barriers and considerations. So why do we care about this? Why should we be bothered about the concept of electronic research notebooks? Well, ultimately, we are producing tons and tons and tons of research data. Absolutely terabytes of research data, which in a way is good. That's a lot of data we can potentially do things with. But ultimately, this data is kind of stored in random, disparate places, down the back of the sofa, in your paper lab book that you've forgotten and left in a drawer, even just on your personal hard drives that other people can't access. So we have this kind of disparate set of data everywhere. People can't share things with each other. People don't know what's going on. They don't know what other people are doing. And we classically get to the point of kind of publishing our experiments, our research, and we don't have everything we need to put together for our supplementary information. And I mean, I'm sure you guys have had this problem. You read a paper or you look at something and think, oh, that system sounds really cool. That code sounds really cool. That data sounds really cool. I'd really like to know what they did with this experiment so I can build on it. Oh no, there's actually either nothing there for me to look at, or what I can see is completely unintelligible. And I mean, ultimately, we are wasting a lot of time, a lot of money, and a lot of research here because we're doing things that people can't build upon. And there are many kind of issues with this, but one of the things we've kind of looked at over the last 10 years, or how can we start trying to combat this, is looking at how we can actually start to record our data better and capture our data better at the very beginning of starting our research, so that when we come all the way through to actually publishing things, we have genuine, useful data and information to actually impart to people, such that we can actually make our data fair, findable, accessible, interoperable, reusable. Now, I think this is always a bit controversial, but I think there's been a lot of commentary over the years, particularly in science, but also definitely in other areas, to say that one of the big reasons that a lot of experiments and research can't be reproduced is because people are using paper. They're using paper lab notebooks. We're still stuck in the dark ages. I mean, if you feel like if you did time travel over here from the past, you'd see a lot of things that, really belie that we're in the 21st century and this is really cool. We sort of have the whole world from Back to the Future. We have people, walking around looking like they're talking to themselves with their AirPods. We have little computers in our pockets. But actually, if you catapult people into labs, seeing them just writing down their paper lab notebooks, they might not think they jumped as far as they had. But so is paper the problem? Well, not necessarily. It is one part of a bigger problem. Paper records aren't always inherently bad. The nature of them being on paper obviously means that they're not as good, to share with other people. They're easily damaged, they're easily lost, etc. But paper can still arguably be better than electronic records, depending on what you've actually recorded. So I went to a really cool meeting at the Royal Society where we talked about kind of scientists' notebooks all the way through from Darwin and the sort of early scientists all the way through to sort of the future and now. And some of Darwin's early notebooks, for example, were very, very well organised, very well documented. You could actually find things. Yes, they were on paper, but actually if you wanted to look through them, you could understand what was going on. There was a lot of information there. And yet I've seen some absolutely terrible electronic records. I mean, just because you put something in a spreadsheet, just because you've written it down on a computer, doesn't mean it's good. So whilst this is an issue, it is not the key issue. The key issue is that we need to actually record more information, we need to record it better. I don't think that the main problem is that a lot of things are stashed on paper. I think a lot of the problem is a lot of things are stashed in here and never get written down on anything in the first place. which is why you come back to it and you have no idea what's actually going on. But yes, we have this we've been going through this paper versus electronic dichotomy for quite a long time. And one of the conclusions of my PhD, which I finished back in 2018, was that people weren't actually ready to give up paper. Because they liked it. It's cheap and it's easy and it's portable and you can have a pen and you can just scroll things down and you're not worried about do I have power? Do I have internet? You're not worried about taking something really expensive into a laboratory. But also people, they like their personal notes and they don't feel pressured to because they're not sharing it with other people. They can write down and do whatever they want. I mean, I've actually been doing a case study with the University of Nottingham and looking at the students. They've got an ELN to write in, and they do write in their ELN, but they still essentially scroll on their digital piece of paper with their stylus first, before they're willing to put it into the ELN. Because again, they like being able to have that nature of just quickly scrolling things down randomly. But obviously there are quite a lot of issues as well with using paper. So, for a start, it's very, very difficult to share it with other people. It's very difficult to actually back it up, and people don't care about backing up their paper records. They don't even consider it. I mean, it was quite funny. Nicola and myself ran a knowledge sharing event with some young students, and they were saying they're really concerned about using electronic lab notebooks because they're really concerned about someone stealing their data. And I said, okay, so where do you keep your data? I said, oh, on this memory stick around my neck. So that's nice. Is it password protected? Like, no. Like, that is a lot easier for me to steal. Like, much easier than working out how to hack into your system, which I definitely don't have the skill set to do. And we ultimately do want to be pressing to put things in electronic systems so that we can share information, so that we can collaborate, so that people know what's going on and that we can actually build on each other's work. But I guess what I'm trying to say here is I understand why people still want to use paper. And I think, when I came to the end of my PhD, I was really thinking, I don't think people are ready to give this up. I will say positively, fasting forward 7 years, I think we are actually progressing to a point where people are more ready to at least think about giving it up. And they want to progress with electronic systems. There's a lot more willingness. A lot more universities are actually looking at implementing electronic research notebooks. We've got good examples, and we've got some good examples coming up in the talks today where people have actually successfully done it. So that's great. We're actually making progress, but it's still hard. And there are lots and lots of things that need to be considered. And there are lots of barriers in the way still. So what I want to get across with this session is it's difficult, it's doable, but these are the things we need to think about. And then we're going to open it up for our community discussion. And yes, this was actually drawn by the wonderful Keris. Over here, was also working with PSDI. This was an image from our first paper together, where basically we tried to impart what are the big consequences of data on paper. So one of the reasons we had a fire, partly because my boss didn't like me using the question, what would happen if you got knocked down by a bus yesterday, and no one could access your work, but also because one of our labs actually did burn down at the University of Southampton, and people lost all their work. And that's a big problem. When I was doing the focus groups with the postgrad students, I said, how do you back up your paperwork? And they said, oh, I have those lab books and they've got the carbon pages and I ripped them out and I've got a second copy of everything. And I was like, excellent. And where do you store them? Oh, in the same drawer as my lab book. Okay, so they're still going down in the flames. So again, something to really try and get across, but it's important. So yes, as I was saying, digital tools should not just be a digital sticky plaster. We should not just be replacing our poor practices on paper with equally poor practices using electronic tools. We should be using our digital tools to capture data better, in a more structured form. You should be able to find your own work better. You should be able to share things. We should be producing fairer data. Because ultimately, implementing these systems is expensive and time costly as well, and involves a lot of effort. So if we're going to do that, we should be aiming to do it well. But yes, as I said, this is difficult. There are lots of things standing in our way. And so I'm just going to run through some of these sort of key barrier and consideration categories. So the first thing is how to actually make a choice in the first place. And there are things you actually need to think about. I've had people come up to me and say, what's your top tip for implementing an ELN? Or I want to implement an ELN. Like, great, okay, but digitizing is great, but why are you doing it? You know, what are your pain points? What are you actually trying to solve? Are you just trying to be digital for the sake of it? Or, you know, what are we actually trying to improve? So at the moment, what data isn't being recorded? You know, what do your current systems look like? What's your current setup? You know, it's not just about, I've decided I want to implement a thing. You actually need to have a proper plan. Like, what are we aiming to achieve at the end? What does success look like for this implementation? Not just thought it might be cool to implement this bit of software. And also, you know, different domains have different requirements and different data types. And I think the other problem is, I think there's a real desire that we could, you know, there could be one ELN or one ERN to rule them all. And that one institute could just put one in place and that will be fine. And I think that some companies where you're working with very specific areas of research within one domain, absolutely that can be done. However, universities, which I think a lot of us are from, and also bigger companies that do cross-disciplinary research, it's actually going to be quite hard to find something that covers all of those domains because they are quite wide-reaching. And you know, things that we found is, it gets complicated. If you have really specific domain things that work for one domain, they won't work for the other, and then people don't like that. If you have things that are too generic, sometimes nobody's happy because it doesn't do any of the domain stuff that people want. But I do think we probably need to dispel this idea that it's going to be really easy to find one ERN for your entire institution. Although if anyone's managed that, I would love to hear about it. And I'd be very happy to admit that I'm wrong and bow down to you and listen to your stories because that would be awesome. I think we also need to think about career level as well. So what undergraduates might want to get out of a tool and what postgraduates might want to get out of a tool are quite different. So I mean, in the teaching labs, or if you're teaching undergraduates, you know, whether that's in science or whether that's in arts, humanities, social science, you're teaching them. You want them to learn. You're not necessarily, you know, whatever they do is not necessarily going to be published or is not leading towards, you know, new research and papers. But it is trying to get them to learn. So we need to be thinking about what are the tools that best aid with that, that best link in with our teaching and our training. Whereas ultimately the postgrad research tools, yes, we are producing research, we are looking towards publication, we are trying to get fairer data. And then having things that go across both those levels, again, that can actually be quite tricky because from a scientific perspective, I've looked at some electron lab notebooks that look very, very, very complicated on the first look. And obviously when you dig into them, they're not as complex as they look. But actually presenting that to a first year who's just trying to do a simple lab, that's really going to put them off. And also that's a hell of a lot of money to spend on licenses for something that has way more capabilities than you're potentially going to need for something lower level. So you need to think about both the people you're giving the tool to, but also the value you're getting out of the tool in the first place. There's also choice, there's so much choice. So these are just a list of the generic notebooking tools. Now, even this has kind of evolved. Like, you know, when I first started this, we had Word. Obviously, we had things like Emacs and VIMs, the sort of command line tools, and you know, Notepad++, and Evernote was more in favour, and we had a few things. But I've definitely, and OneNote was, of course, but I've definitely noticed more note-taking apps come into the fray, and I'm sure that this, I don't think this is an exhaustive list, by the way, but this is just to kind of give an example that actually even with a generic note-taking tool, there's quite a lot of different things, down from like really generic text editors, to kind of full-on word processors, but also note-taking apps that come with quite a few other different bits of functionality that have kind of to-do lists and tasks and more project management things embedded. So even that is hard to choose, because you've got to think, well, again, what am I actually trying to achieve? Do I need any of these project management features? But I probably need some structure. So I don't necessarily want something that has nothing in it, but do I want something really complicated? And again, and also, what do we already use at our institution? How much are we going to have to pay for the licenses? Because actually, I've gone through and tried some of these note-taking apps, and they look great until you realise that actually to do any collaboration, suddenly it's going to charge you a really hefty bill. So that can be quite hard to just decide on. And there's now over 85 active electronic lab notebooks on the market, which is kind of mad. When I started my PhD, there were over 80. Bear in mind, that was back in 2014. Now there are over 85. And this is not, yes, Anne?
Does this include ones that companies are building in-house, or is this literally just ones that you can buy off the shelf?
These are ones you can buy off the shelf or that have been registered in anything like ERN Finder that we have access to. So yes, that's a very good point, Sam. There are almost certainly many more that are in-house ones that people aren't willing to sell or aren't making available to others. But in terms of on the market, there's over 85. And I mean, ultimately, when I first started looking at these, yeah, there are about 80, some of them have disappeared, some have gone bust, some of the open source ones are no longer kept up and they've kind of, the websites have disappeared. Some have been bought by other companies and new ones are still coming up. Pretty much every time I go to a lab conference, there seems to be a brand new electronic lab movement. So choosing between these is really, really, really tricky. And again, I will sort of briefly talk about the GIST DPS system later in absence of Gary, but yeah, there are things that are trying to help with this. But it is tough. I think we also need to consider our institutions and our infrastructures. So there's quite a few different things you need to consider if you're actually going to embed one of these tools, whether you're trying to go for the whole institution, but even if you're trying to go for a whole department. You know, from personal experience of literally just trying to do this over the last sort of half a year, there's a lot of other things you need to think about. And it is not, you know, even if you've got all the way through, you picked your software, you've made your decision, you've got the money to pay for the licenses, that is not the end of the story. As our head of chemistry was not very pleased to him, but it is not the end of the story, it's just the beginning. So you also need quite a lot of admin support for electronic research notebooks. So again, if you were using something like OneNote, obviously most people already pay for 365. If you're going down the generic route, so chances are that could be set up with less hassle, but you still need someone to come on and administer and do templates and work with. I mean, Philip did a hell of a lot of work just getting set up for one lab, and you know that was a lot of dedicated staff time just to get that working. So then, if you consider you were going to use that across a whole range of different teaching labs or teaching classes, you would need support from a lot of different people to actually get that going. And you need people to actually do that work, and you need people to actually work with the lecturers to make it work. Again, if you're doing something that's open source, you need developers. You need someone that's actually going to set it up and monitor it and make sure that all your data is stored properly and make sure that everything is backed up and it's installed, and that you have people with that technical knowledge, and also make sure there's not a single point of failure. You can't just have one snazzy tech guy who knows what he's doing. You need a whole team, because otherwise that's not going to work, and you don't want things to fail because someone's on holiday or someone leaves the job. So you need to really make sure that that's set up as a robust system that a lot of people can maintain. And you also need to think about all the accounts and roles and groups. Again, for any sort of new system, are you going to integrate that with your own sign-on system? Is someone going to have to administer a whole new set of accounts? And how do those link into your main accounts? That's a lot. And then who has all the privileges, who has access, who can see what? That's a lot of work. And you also need to think about what happens to the data when people move on, because you don't just want that to kind of sit in the system where no one else can access it. So you also need to have procedures in place for that. There's also a lot of cost. So it's not just a case of paying for licenses. If you're going to be expecting that people are going to be using these electronic tools, you need to make sure that the environment for those electronic tools works. So you need to be, you know, whether it's in a lab or whether it's in lecture theatres or whatever, if you can only use electronic tools, you need enough power sockets so that everyone can actually plug in their devices. You need the internet to be good enough. So you actually need people to, you know, whether that's to have good Wi-Fi routers or to have, you know, the capacity to plug in computers. Again, if it doesn't work, kind of people aren't going to be able to use it. And then you might have development costs. Again, if someone needs to actually write some plugins for it, work on and install and run a whole open source piece of software, that doesn't come cheap, and you may not already have that in your staffing budget. And again, there's always going to be maintenance, hardware costs of actually having devices to use for these. So, and actually where I've seen some successful implementations of electronic research notebooks have actually been around university refurbishments, where they've actually, you know, refurbished, say, a laboratory and then actually put these things in place as part of the refurbishment and have been able to get hold of devices. So do need to really think about all of these other costs if you're putting it into your budget. Time. So for anyone thinking this doesn't take time, you are wrong. I'm afraid, unless you're somehow a magician. You need to think about all the time to set up your systems before you actually launch it and get going. You need to train people in how to use it. You need to think about how moving systems may impact people, like people may be moving from existing systems, existing tools. How long is that going to take? What's that going to look like? You know, how are you going to handle legacy systems and legacy data? I mean, shout out to Sam, who's our other PSDI person who appeared. He has some funky tools which he's made available for free by PSDI. So we're not big vendors because it's free, but to actually scan in paper lab notebooks and turn them into machine readable data. But again, you have, even if you start with something now, you still have all of your legacy stuff in a different format. So you do also need to consider what you might be doing with that. And again, yes, ERNs, I would say, even more complicated. Convincing people in the institution that they want it, that they're going to use it, that they're going to pay for it, getting approval, setting up your labs, getting the staffing, potentially running trials, developing templates, the logistics. So I think Matthew and I started talking about our electronic lab notebook trial in, gosh, summer last year, and we launched it in January. And that was with dedicated staff time, quite a lot of meetings, and us spending quite a lot of time on it. So, and that's with 50 users. So, you know, I don't even want to think about what it would have been like if we started with the whole department. And yes, hardware is a real big issue. So you need to think, in what circumstances are my researchers going to be taking notes and recording their data? So, you know, if you're in a laboratory, there's always concerns about cross-contamination. So you don't want to take your computer in, potentially spill chemicals on it, ruin it, but also even just touch it with chemically hands, and then, you know, take it back out to your office and eat your lunch. Like that's not safe, and we should not be doing that. And one of the things that people have done to subvert that is have dedicated lab hardware. That hardware stays in the lab, it does not leave the lab. You have separate hardware in the office. That's safer, but then you need to pay for twice the hardware. So again, that links into the cost. But also, what if you're an archaeologist and you're out on a dig? You know, that is also potentially going to be quite tricky, because then you're thinking, well, do I have internet in my field where I'm doing my dig? And is that safe in my computer? Am I going to drop it down some big hole? You know, so there's lots of things to consider in terms of the safety of the devices, but also the environment, and whether you're actually going to be able to use these things effectively. Will things be interoperable? So considering compatibility concerns. And again, how are you going to charge these devices? How are you going to power them? Can it be used offline? And what's that thinking look like in terms of data loss? And then, of course, there's all the data considerations that we need to think about. So, as I said earlier, a lot of people mistrust digital tools, particularly if they don't know where the data is stored. So, and I really say this is a very strong thing everyone should think about. If you are bringing in a new digital tool, you should already have your data exit strategy before you put any data in. Because you do not want to get locked into something. You know, what if people put up their prices? Or what if the money for running this project runs out? Or what if just something goes wrong? We need to know that we haven't, you know, blindly got our researchers to trust us, put their data into the system, and they can't get it back out again. So, I mean, we've actually implemented our own additional backup system where we pull data from the API and we store it somewhere else, so that if everything goes wrong, we have external backups. But again, we have technical expertise in our team, someone who can write Python scripts, has access to virtual machines. We've already spoken to our technical team about like how we can do that more properly when it comes to a bigger departmental setup. But that does need to be thought about. But also, we need to think about where the data is stored. So universities and institutions will have regulations about where the data is allowed to be stored, which then gets into concern depending on what providers you might be using and where their cloud servers are stored. So you need to make sure that potentially there are options for the data to at least be, you know, cloud, but locally stored within your university. And again, thinking about security measures and vulnerabilities, I mean, I think we've all seen the British Library sort of big hacking scandal. That was a massive issue. You know, I would like to think people won't waste their time trying to hack universities and get all their data, but equally people might. I would like to think they wouldn't do that to the library if they did. So again, thinking about that security side of things and making sure things are actually protected. Because as much as, yes, people can get overly concerned about where to put their data and where it's stored, it's not entirely without reason. So data capture and templates. So different domains will need different templates. You know, what a historian, what a chemist, what a physicist, what an archaeologist, what an English scholar, well, they're going to capture are very, very, very different things. And so we need to work with the domain experts to understand what type of data we're trying to capture and where we need to, where things are missing, where things aren't going well, and how we can do this better. And Keris is going to talk about the pitfalls of templates, because whilst templates can be very useful, if they're done wrong, that can also be a massive issue. We need to think about data formats for import and export. So how can we get data in? How can we get data out? What does that look like? What do we potentially lose if things say only come out in PDFs, which is not helpful. And thinking about the different types of data that will be recorded. So again, this is all kind of gearing towards trying to make sure that we're not just implementing a tool for the sake of it, we're implementing something that's actually going to improve the quality of the data that we're capturing. Which then, yes, leads to sharing and publishing and fair data. So a really key reason to implement these tools is to produce fairer data. And to me, that should be one of the biggest success criteria that you are looking for in terms of running the, in adding these systems. So you really need to have a plan for what's that going to look like, how are we going to measure it, and what are we going to do to try and push people towards that. And also sharing data amongst colleagues. It'd be so much more useful if students could look at each other's work. Oh, you've done that, or you've had that problem, you've looked at it in this way. Or again, people leave. Oh, so-and-so was doing that in the lab 2 years ago and he's left. Oh, great, no, it's fine. I can still access this data. Let's have a look. That's great. Rather than no idea where it is. We're just gonna have to start again, which I think happens quite a lot. And change management and adoption. So what I always kind of say is we are the biggest problem. People are the biggest problem. In fact, we talked about specifically. we talked about barriers and challenges to fair data at the conference I was at last week, and I did one of the funky work we're about to do soon. And people was whacking right in the middle of everything as the biggest barrier. But I always say, not the worst thing, because if we're the problem, we have the most influence on being the solution. So if we are all working towards doing our research better and using these tools, that is a good thing. But I mean, ultimately, top-down influence can make or break this. Groups will be led by their supervisors, led by their lecturers, departments will be led by their heads. You do need to get the people on board, because otherwise it's just not going to work. And people are concerned about changing processes, and it's hard to suggest that they suddenly start doing a lot more work or doing it in a different way if they don't understand the benefits. I mean, our strategy to mitigate this has very much been to identify early adopters, first years, new starters, people that haven't necessarily done it another way. So we're not trying to change people that have been doing it for 10 years. We're going, oh, new people coming in, this is a shiny thing, let's try it, and let's see if we can get it to work, and try all of that with, and the people that really want to do it, and then use that as our sort of initial trial set.